So, but again, I don't want to be too harsh about it. I know we're people.
Just because I made a mistake for the YouTube, so just I'm fixing the YouTube podcast and we'll start soon. If Tom, if you want to start the, let's say, introduction for it, I think you can start now. It's okay.
Very good. Very good. Guys, I'm very honored that you signed up for this class. We're making a serious commitment to you to treat this as something important in your growth, something important in your future. And make no mistake, we are here to grow together as data scientists by learning a set of best practices, the machine learning pipeline. Learning to use this pipeline in your machine learning work will align your minds with many great intellectuals before us. And after using the pipeline many times, your conceptual understanding will increase and your abilities to conceive new and unique AI problem-solving methods will begin to develop. And guys, our amazing TAs and I are honored to grow and learn more together with you. And guys, you can start the slides when you're ready.
Yes, Tom. Before starting the slides, I want just to, from your side, because I got this idea from you in a very good way, so I want you to tell them. When we are talking about the data science, we are, since you are from engineering background and somehow I'm from software engineering background, we think that it's part of engineering. If you are able to give us a small introduction about this and why data science is part of the engineering sector, let's say.
I would be honored to do that. When I was going through mechanical engineering, it became very clear to me that to do well in this discipline, for example, learning statics, dynamics, strength of materials, I could see two things over and over. We were breaking complicated concepts down into components and understanding how they relate to one another. Think of vectors, think of systems, think of any analysis you've learned to do. All of them are a set of best practices and methodologies. Now, I'm not trying to criticize anyone out there in our field of data science, but I see this missing. To me, when I look at, people will ask me, how did you transition from engineering to data science? And my mind's like, I didn't transition. I'm just practicing something I've been practicing since I was a freshman in college. But it's advancing, it's growing. So I'm learning that too. For example, multi-physical system modeling expert, control system design expert, having taught it 5 semesters, but everywhere I turn, methodologies in the way you design the system, the way you analyze the system, the way you code the system. This is the rich heritage we're bringing you from the great intellects of our past, from the many great engineers of our past, to say, what is the methodology we should follow when we do machine learning? And it is this pipeline. I wish I could speak Arabic, but again, it's a set of best practices. It's a set of in-order steps. And in fact, the Arabic translation will say steps in order or something like that. Guys can correct me. But guys, what's cool is we're going to learn this pipeline on some examples, and then we're going to practice it on those set of examples all the way through, and then we're going to repeat it many times until you feel like, I've got it. I see it now, and you see how it all relates. Guys.
Thank you, Tom. In fact, in Arabic, it's set of tasks or list of tasks, let's say, or an order. with order. It's one word in Arabic, rattle, and it's mean all of this together. So I will start sharing my screen. Today, with this, I think everything it's becoming clear with this introduction by Tom. So today, when we are talking about the machine learning pipeline, that we are moving or speaking about moving from machine learning modeling to machine learning production. And what is the difference here? The difference it's shown when we are talking about proof of concept, or we are talking about a product that will serve a huge amount of requests. So let's first explain what is the machine learning modeling, or let's say, remember what is the machine learning modeling. In machine learning modeling, we have a data set or set of data that describing a problem or a task that we are looking for. And then we will try to select what is the most insightful and most predictive, let's say, pieces of this data, which is we name it features, and do some kind of engineering or modifying to suit the training process that we have. Once we are happy with the data preparation, we will go for to choose the suitable model to train it, and then after the training, we are going to evaluate it. If we are happy with the evaluation matrices, we are done and we have our model or proof of concept. So according to that, we show our point of view or we finish our research. Otherwise, if we are not happy, we are going again back to the data to find more predictive features or to do better feature engineering, or even changing the structure of the model or fine-tune it. All of this together with some number of iterations at the end will lead us to the model. And once we have a model, we are happy. So according to that, we can, since we know that the feature engineering process, the training process, and the evaluation, all of them are mathematical processes. So we can define the machine learning as the following. And this definition, it's from Dr. Tom Ives. Okay, it's the development of use of processes that are integration from multiple types of math running on computer systems that are able to learn and adapt without following explicit instructions, and they are then used to analyze or draw inference from the data. So with this, let's say, definition for the machine learning, we have to understand that machine learning, it's a part, before going to the next move, to the next step, Tom, about this right now, about this introduction, do you have anything to add before moving to that?
Thank you for the good introduction. And I would just add, don't feel constrained by this definition. We're just trying to put it in a small, this is the elevator speech definition. And our terminology is in flux. This is our best effort as we write our textbook to say, based on the definition of data and science and what you see on a Google search for this meaning, what would we add to it from our unique perspectives? So don't be afraid to add to it from your unique perspectives.
Okay, thank you, Tom. Now, just I want to tell everyone that in this session, it's introductions. That means we are trying to create some kind of boundaries, some kind of understanding for how everything is structured together, how it's linked together. And then it's very important to know exactly what is the machine learning pipeline. When we finish this session, we will find that at least in our head, in our mind, we are clear where we are acting and what's needed. And what's the meaning of automated machine learning pipeline? For today, we don't have assignments, but we have a kind of set of concepts together just to give us the landing for the course, for the class. Now, we don't have to forget, or we have to remember that machine learning is special kind of data science models. And the data science models, which is the bigger models, it can be machine learning model or other kind of models. Let's have a look, let's take a look about what kind of model that we might face on the machine learning. First, when we are talking about the data science modeling, it's good also to take a look about how we are able to define the data science. I'm not going to speak about this. It will be these resources, all of this, the slideshow and other references, it will be shared with you after each and every session. But the machine learning experiment, or the machine learning, the data science project, we used to name it experiment, and the experiment output, it's the data science model. The data science model, it can be one of the following, let's say, it can be reports. And when we are speaking about reports, we have to see what's the good, what's the meaning of the good report. So the good report, it has to be clearly written. It has to be narrative around the data. That means it's showing what's exactly data given to us. Show the creation process of the analytics. It's very important for the good report to know how we get this report. And it has to be clear, it comes with clear conclusions, and it has to be reproducible. That means we are able to reproduce this report with another set of inputs under some configuration or settings. The other kind of output, it can be presentations. And whatever we said on the report, it can be said on the presentation. The same terms that we can use it to define what is the good presentation. For sure, there is some visualization come with the presentation, but at the end, it's doing the same. The third output expected, it can be application or services. And application or services, there is a clear example. You can ask us what is the data science experiment that lead to application. I will give you example from the history, but it's real. When somebody started previously in Italy and other side of the world, study what the accounting system that they have, and depending on that, they comes with a new model, which is named right now accounting model or financial model, and it's used by, let's say, wide around the world. This is kind of data science experiment comes with application as a result. So yes, sometimes we are able to find that the result is application or services, and for sure we are able to come with machine learning models. This is the output of the data science modeling process. Now all of this, we are able to run it under what we name it as a management model or management methodology data science lifecycle. So right now this infographic is just to tell us how each and every concept is related to each other. So what is the data science lifecycle? It's explaining the phases or the steps for each and every data science project. So if we are able to, that means it's management model. It's not something technical. It's how to manage this project. So if we are able to define a well data science lifecycle, it will be very useful for our team to come with the common vocabularies and to share mental model so the work can be done faster and in a more accurate way. So again, the data science lifecycle, it's containing the data science modeling process, which is one of the types of data science modeling process. It's the machine learning process. Just to have a brief, let's say, description. Sorry, Tom, anything you want to add?
Just real quick, just at the risk of sounding very unacademic and sounding very non-business-like, you're gonna, I know you guys have heard me say this before, and I hope you don't grow tired of it. Learn to care about the organization, about the human needs that you're serving. That's what drives this data science life cycle. It's just to make sure that you're caring about what you're delivering, that you're caring how you're communicating it, and you don't need to show off. People know you're smart. They just need to know what solution you're bringing to them, what predictions. But excellent points, guys.
Thank you. So if we just move to describe what is, in general, there is many ways to implement the data science life cycle, but all of these methodologies, it shares the same steps. Now, how these steps it's interactive to each other, it can define what is this methodology or what is the another methodology. In general, here I'm starting from data understanding, but there's one step behind it. It's the step 0. It's the business understanding. Why I remove it from this graph? In fact, just to tell us that when we are understanding the business, for us as running data science Experiment, it's not meaning that we are cloning the same method of working. We are understanding what they have, and then we are comes with our studies to come with more with another experiment to make the let's say the work or the task performed in better way. So that's why I element from here. But the first step, in fact, it's understanding the business, then understanding the data, then make the data preparation, the modeling, evaluating, and then deployment. Now we are able to stop on the evaluating and move, and it will be iterative process, or we can go with the waterfall. That means we are only building proof of concept, then we will stop at that point. It's depending on the question that we ask in the beginning. What is the question means? What is the task that we are looking for? Maybe the task itself is only testing one neural networks or one architect, neural architect, to see if it's suitable for this or not. Maybe it's not important to be iterative. So depending on what is the question that we have, we can decide which implementation of data science lifecycle we are going to use. Now, data science lifecycle in general, it's expected to be iterative, but yes, we have to prevent the iteration that delay the project. Yes, also it's enabled compounding collaboration by creating components that are reusable on another project, which is very important. This is what is the principles of data science lifecycle. Each implementation of data science lifecycle has to keep these in mind. And also auditability needs, it's always there because yes, we need to know why and how this model act like this. Now, in general, right now we understand what is the machine learning, or we are able to understand the boundaries of machine learning model and how it is special kind of data science model and how it's embedded or it's part of the data science lifecycle. Until now, we didn't speak anything about the machine learning pipeline. What is the machine learning pipeline? Let's first create kind of boundaries or understand how to locate it in this infograph. So it will be like this. The machine learning pipeline, it's part or it's covering many parts of the data science life cycle. If and only if the modeling of the data science, it's machine learning model. So the machine learning pipeline, it's covering a set of tasks from or phases from data science life cycle if we are dealing with machine learning model. This is the first, let's say, idea about it. Second idea, just I wrote some notes. I want to go back to it. Okay. The machine learning pipeline, it's methodology implemented when we are talking about machine learning engineering. That means when we are moving from the modeling process and proof of concept or research and go to think about deployment and development of this model and how it will act with the data lifecycle, which is this data showing seasonality or it's even valid for a specific period or something. So here's where it is it's located. But what is it? What is the pipeline? To understand again what is the pipeline, until now I'm just run away from defining the pipeline to just give you all the concept that we have. When we are talking about the machine learning process or the machine learning production process, we have two sides of concern we are focusing on. The first one is the machine learning development concern, which is we have to think about the data labeling and how it's happened and what we are able to do to make it better. The feature space coverage, which is we are going to speak about it later during this presentation, but at the end we are able to name it that is our data set cover the old feature space or not. Dimensionality reduction, it's very important, and we have to use the suitable dimensional data or features to get the suitable prediction. Maximize the predictive data, fairness of this data, and it's very important to, it has not to be biased or let's say, overfitting some cases. We have also to consider the rare condition that might appear in the data, and it has to be, let's say, represented in our data set. And also the one of the most important concern we have is the data life cycle management, because this data is maybe we are able to trust it for a specific time period or specific situations, but it will be not considered, for example, it's suitable for winter, but not suitable for summer, something like this. This is the machine learning development concern. But also there is another kind of concern which is related to the software development concern, because at the end, this machine learning models, it will be deployed as a part of, let's say, modern software development lifecycle. So issues like scalability, which is how much the user is able to use this model, extensibility, configuration, how it will be managed, consistency and reproducibility, testability of the model, and safety security, all of this together, which is we use to consider it in our software development lifecycle, it has to be here considered also. So right now we have two kinds of concern. Tom, before moving over, anything to add here or any notice from your side, please?
This is so good, and we know too. Geith and I discussed this. We don't want this to overwhelm you at this point. Treat this as we're all going to take a long, difficult hike together to look at some beautiful scenery. We're just tour guides explaining what the journey we're going to take you on. But all of this will make more sense as we go through the main examples and examples after we complete those main examples. And I would only add one additional point. 95% of the time, Geith's right, we're being led by business needs, but do be aware that all of these arts can be applied equally well to just human needs in general. It doesn't always have to be business. For example, AI for good activities. But yeah, 95% we're seeking to serve our companies that we're hired by.
Okay, just I want to add one thing before moving over. Why we are explaining all of this, as I said in the beginning, we are trying to create the boundaries of this class and to understand exactly what is the machine learning pipeline. So right now we are showing that we have some concern we have to focus on. We have some, let's say, tasks we have to take care about when we are deploying our model for, let's say, for production. We will start from the data generation. It's a task itself, and data preparation. All of this starts from data cleansing to process kind of how to split the data into training, or all of this together. It's one concern we have to think about. And once we are happy with the data, we are to think how to train our model and what's the best methodology to train it. And right now, even this itself, we are we going to run experiment on the cloud, or we are going to use kind of distributed training? All of this also another kind of concern. Why this is mean a lot in research process, for example, maybe we are not going to think about it. We are going to check what the model will give to us. But when we are going to go to the production, reducing the cost and managing the cost, it will play main goal. So that's why each and every step, each and every task of this, we have to take care about it. After that, how we are going to deploy it and how to serve it, including the software concern that we have previously, and how to monitor the performance of this model. And this monitoring, will be frequent, or according to some change in the performance, something will have to give us kind of alert, or to tell us that, yes, there is something appeared and maybe the model needs to be retrained. Assessing this assessment of this performance in regular basis. Again, consider the ability for continuous integration with the new components and continuous development of this model. This has to be, once it's in the process, you cannot stop it. So when you are going to enhance it or retrain it, you have to think how it will be deployed and published once again. So all of this together, it's kind of task we have to think about it when we are building our machine learning for production. That means machine learning engineering process. And
Guys,
at the end,
remind us what CI/CD stands for, please.
Continuous integration, continuous deployment.
Thank you.
Okay. And at the end, all of this has to be performed in, let's say, with a clear, let's say we have to reduce the cost as much as possible. The cost management and the resource management is playing the main role here because we are talking about business. We are talking about something going in the production. So right now we show our tasks, our concern, according to that, and where the pipeline is located. So according to that, we can set easily that the machine learning pipeline is kind of framework, will help us to automate some tasks, monitoring the task, and maintaining the models for training and deployment. So together, all of this together is the definition about the framework. Pipeline, about machine learning pipeline. Tell me, yes.
Yeah, very quickly, guys. So guys, this is so well communicated, but one thing we can't prepare you for, we can only guide you through it once we start hiking through the code and the actually practicing the machine learning pipeline in Python is this. You spend a lot of time formatting your data, getting it in the right format so it can be ingested by the models. And really, you will get some experience with that, but how do you get like real world experience? You get very good at Python. If you practice with the scikit-learn data set and you practice with things on Kaggle, you can get a little good. But I just want to prepare you, if you focus on your Python skills and get good at the things we will show you, you will be well prepared, but it's still a challenge once you hit the real world. I just want to warn you for that.
Okay, thank you, Tom. Here also one thing I want to say. When we talk about framework, maybe who is coming from software development or software engineering background, he would think that we are talking about physical framework, that it's something kind of library or tools, it's already there. Yes, we have this kind of physical framework, but at the end, we are talking about logical framework. That means we are creating set of a process, let's say, all with special order together, will tell us what we have to cover when we are doing a machine learning product. So this can be prepared by ourselves, can be prepared from code from scratch, and we are able also to use some frameworks to help us on performing that. But at the end, we are talking about the concepts here and how this concept we are able to implement it in our, let's say, machine learning production or machine learning experiment. So it's good to differentiate between the logical framework, which is something we are studying, and the physical framework, which has extra, let's say, efforts needed to use it, or also, but it will be also faster to implement because, yes, it comes with all the, let's say, the engineering part related to it. Now, the target of the machine learning pipeline is to create integrated machine learning system, operate this system in production, handle the continuously changing data, and optimize the resource cost. So in general, this is the most important. If anybody able to find a methodology that able to meet these targets, then it's his pipeline. But we are trying to go for the, let's say, the best practices, that what's right now it's implemented on the world, just to tell everyone that, okay, this is what other teams, other companies try to do. So we are able to copy or, let's say, clone this experiment from them. And then for sure, we are able to add our, all of us, our part or our vision to it. Now, what is the best implementation of the pipeline? It's just like a directed acyclic graph. Now, directed, that means when we are moving, it's a graph at the end, okay? But each node of this graph, it's considered a task that we have to take care about it when we are implementing machine learning product. Now, moving from one task to another, it's directed move. So we are unable to consider that we are able to back again. That's why it's pipeline. The word pipeline has come from this concept. And also there is some rules, let's say, determine according to our implementation of the pipeline, how to go from one task to another and what will follow what until we reach to the desired, let's say, desired result. Now, since it's acyclic, that means it's not iterated. Most probably it's not iterated, but there is some, let's say, iteration might appear. Okay, since it's acyclic, that means yes, we are expected to be automate some of or whole the pipeline that can be automated. But during the class, we are able to check what will be able to automated to be effectively automated and what's it's under research and what we are right now just trying to understand. So this is the best, let's say, idea to think about this machine learning pipeline. It's just like a graph, directed graph. Tom, anything to add here?
I really like this graph. It may confuse you guys right now, but it's the best illustration I've seen of the fact that sometimes we just have to jump around in the pipeline. But once you see how the pipeline interrelates and it's not extremely linear, you will have superb insights into machine learning, and it will be like I introduced. You'll just start to see things in a better way because you've aligned your minds with the pipeline, with the methodology. Thanks for this slide, guys. It's really good.
Thank you, Tom. I will try to finish in 5 minutes just to be strict to the time. Okay. Now, according to, since we are talking about continuous deployment process, so one of the foundations that found that this is the task of the pipeline. And right now we are just linking to each other as pipeline, but at the end, just keep in mind the graph. That means each node here, it's node in the graph, and we are able to move from one node to another. I'm not going to explain these slides, just small words about each node, because this is in fact the class. We are going to discuss and explain more about this during our session. So we will start from the data cleansing. Most probably we have a data set, and then we start with the data cleansing. Data cleansing might be about the missing values, about values in wrong format or whatever. And then we are going to go for data ingestion. Data ingestion, it's how this data it's loaded and presented to the training process or to the next step of the pipeline according to what is the next step. It's very important to understand one thing. Whatever we mention here, it's not a standard. That means not all the teams or all the companies, they are following all of these steps. But this is the most general one I was able to see. So according to that, we can choose what's the task we are able to build in our pipeline. But yes, we are trying to explain all of this or to show all of this. Then we have the data transformation process, data validation if the data is valid and we are able to use it in our experiment or not, feature engineering, how to implement this feature that we have, how to change to transform it into another form if it's needed, data splitting and the train, validation, and test sets, and what is the best method. Maybe we are going to use Caffo or something like this. And then we are moving from data preparation to the modeling. And then we are going to build the model, train it, evaluate it, and training of scale according to the evaluation matrices. And then we have a model. Once we have a model, we are going to think how to implement or to deploy this model to the real life, to the production. And here, when we are deploying, we have to think about edge deployment if we are going to deploy it on the, let's say, on the peripherals or cloud deployment. We are also have to think how this model is going to serve the request from the users using the current data, the new data that's implemented, and then explaining why this results and logging the results appeared. And also sometimes it's very important to debug the model why there is something wrong appeared. Okay, all of this task in the pipeline, and then fine tune and optimization, and might lead us to build the model once again. So we can see there is a kind of iteration might appear, and all of these tasks together, how it will be interact to each other and how to move from one task to another, it's happened with the usage of what right now we are naming orchestrators. That means all of this task has to be, or there is kind of orchestration to work in the perfect way and an automated way. Now, orchestrators, mainly it's kind of framework or let's say methodology also again. It's help us to decide which task we're going to follow by which task and according to which terms. And there is some frameworks it's already here. Orchestrator is already ready to be used, and also we are able to build some kind of our self-orchestration method. So we will speak about this later during the session. Tom, anything to add here? I prefer, in fact, I can continue to speak about what is the feature and what is the sampling of dataset. But in fact, because we already passed the time, I prefer to keep it to the next session because it will be related to the next assignment also. So at the end, we are going to add it, yes.
I actually think, first of all, I wanted to say the last 3 slides were really key. And if you can go back 1 slide, guys, I wanted to highlight something. Oh, 1 more again. So right here, if you remember that very non-linear slide that had all of them connecting, please do understand it's not as linear as this is showing. We like to show it this way, but sometimes when you've done the feature engineering, it points something out to you that makes you look backwards. Or once you do the training with a certain type of model, it illustrates something to you that makes you think you have to go back in the pipeline. And that was the importance of the previous slide that showed all the interconnections. Those dots in that previous slide are each of these valves in the pipeline. Yes, exactly. So, but you're thinking, I don't know how to do that yet. Of course you don't. And that's the kind of insight you will gain as we go through the example problems, the example projects, I should say. And guys, I think we can go a little past our 8:40 transition time because it's going to take us time to get into the normal lectures.
No, I think Tom, I think the coming slides we can just delay it for the next week. I will show you what is it exactly. Data set sampling and how we are dealing with samples and what's the meaning of that. What is the features as a definition? What is the labels as a definition? And what is the feature space? All of these concepts, it's related directly to the next session, so we can keep it to the next session.
Excellent.
And right now we are, if there is any question from anyone, I think we are able to move to the next step.
Just real quick before we go on to questions, I want to point out to you guys, we're easing ourselves into introducing code, and we're going to introduce a very important skill to you that we haven't mentioned yet, how to create valuable fake data. And I cannot emphasize enough the power of creating fake data, because when you know how to create fake data to test your routines, it's your way of saying to yourself, I know the kind of things that my machine learning algorithms are going to run into, and I need to test those corner cases. And when you can do that, it's powerful, but it's not as hard as it may sound. Okay, questions. An excellent job, guy. Thank you. That was a new slide set, and I'm just so glad he did it.
Oh.
Use the hand raising thing too, but yeah, Jonathan, please go.
Sorry. So just looking at the life cycle part that you had listed, the 1 to 5 points, and then you left out the 0 understanding the business problem. Have the business understanding. Can we? I mean, looking at this looks like that we can apply the crisp DM method to this life cycle. Is that correct way of thinking, or is it slightly different?
See, sorry, Tom, if you want to go.
No, I want to hear your answer first. But I was only going to ask for clarification, Jonathan. I'd not heard that term before. Did you call it the crisp?
Crisp DM.
Can you type it in the chat?
I have heard.
Yes, crisp DM. I think it's
cross.
Crisp DM is basically
that's it.
Whole pipeline only.
It's not pipeline.
It is the whole life cycle of.
It's data mining life cycle. Let's say. It's exactly. and data mining at the end, it's the project of data mining. It's kind of data science project. So this, let's say, matching that you are able to find, yes, because my reference for this session, it was coming from Domino, and Domino, it's kind of cloning the CRISP DM into data science lifecycle. As I told you, data science lifecycle at the end, it can be implemented in multiple ways. So one of them, it's what they have on CRISP DM. This is the first point. The second point, when we are, why let's say, I want to mention something I didn't mention clearly on the slides, but I was running around it because I want you to understand it. The pipeline, it's implementation of the technical task of the lifecycle. That means whatever technical, it's not managerial, whatever it's able to be automated, we are able to add it to the pipeline. And since it's related to the machine learning. So this is my understanding about it. If you remember the infograph, we are showing that the pipeline, it's included in the data science lifecycle because there is some tasks, it's outside of the pipeline. And then once we decide that we are going with the machine learning model, we are going to start the pipeline. But most of the tasks in the pipeline, it's purely technical. It's not kind of management tasks. It will be included on the iterated process of the data science lifecycle. The third point, it's about why I remove the step 0, which is business understanding. I think Tom will explain this better, but I will say what I mean by that. When we are understanding the business, we are risking on following the same methodology. On the other hand, we need to use the data science, we use the data insights to come with better methodologies or better findings. So understanding the business itself, it will tell us it will lead us to understand the data, but we don't want to risk in following the same methodology of the current business because maybe they are doing something and we are able to find something better. I also want to listen to Tom about this.
Yeah, this is really important. I try to keep this simple. It's really about getting out of your chair, talking to the business leaders, and finding where data can best help their concerns. Let's imagine that you have better business acumen than your business leaders. So what? They don't care about your business acumen. They care about what they're scared about, what they need to know about. You need to guide them to show them how data can help them. And that is why we talk about personal skills so much in our mentoring sessions. Brother Greg, what's your question, buddy?
So for me, can you guys hear me?
Yeah.
I wanted to say, do you have a list of like the full stack of tools that we might need for this? Like, for example, Colab or anything for deployment and things like that. And then the second side of my question is, how much of concentration will there be for data manipulation? For example, pandas or things like that. Are you going to be focusing a little bit or a lot on this side of things?
Oh, very much a lot, Greg. Thanks for bringing that up. We'll talk about IDEs you can choose from. We'll talk about notebook usage. We'll talk about how to deliver your models quickly and easily. We're going to ease into all of that. We're not going to cold shock you with it like jumping into cold water. So very good point. We'll get those notes out ASAP. In fact, I'm even putting together a post on how to create virtual environments to help you guys with that stuff because it's so powerful. Kim, please go.
Tom, I have actually one small question.
I'm going to just, Saurabh, I'm sorry, I'm going to take them in order. Okay. So use the hand raising thing and then you'll get in the right order. Kim, go.
Okay, I'm hoping that this is not going to divert too much if Saurabh was on topic because this is a different topic. So if Saurabh's question was related,
yeah,
then maybe
just go. It's okay.
So my quick question is, this goes back to the DAG, the data science lifecycle, where you're talking about the directed acyclic graph. I'm curious, theoretically speaking, are you suggesting then that the iterative processes of let's say when we're talking about the prediction analytics and the weights that are involved with the different hidden layers, if there are hidden layers that we're talking about in the model, are you saying that the iterative processes of going back and determining the weights is within that DAG? Or in other words, like where does the iteration come in where you can change the weights?
Well, so part of the iteration is just in the model training, how the weights get updated during the training.
So you're talking about setting up the weights automatically?
Yes, but Kim, what can happen is, and we'll get into this as we go through projects. It'll become clearer and clearer the more projects we go through. But sometimes you're just using a model to gain insights. Sometimes you're fine-tuning a model's parameters or its hyperparameters to just get better results. Right. And that'll become clear as we go through the project. So I wouldn't worry about those details at this point, but it's good to start thinking that way. Okay, Shantanu, please go.
Sorry, Tom. I just want to tell that, yes, just to have it clear, it's one node on that graph. It's the training, and all of these processes that you are asking for, it's inside that node. So this is what we are able to say.
Shantanu.
Thank you. So my question is much more of a general kind. I think I missed the starting part of the lecture. So what I need to understand is, the first question is, how long are we planning on doing the whole this series kind of thing? Like, is it a 2-month, 3-month kind of piece? First question is that. And the second question that I want to understand is, I understand that is completely based on the machine learning pipeline. So what are the specific pieces, for example, that we will be doing? Like, I understand the starting part of machine learning pipeline, the data preparation, modeling, training, and all those parts. I want to know if we are going to focus on the bottom row that were shown in the slide, that what you call, whether we are going to go for a cloud or an edge. And then I think there were 2 or 3 more topics that were written. I don't remember the name, like CI/CD and all those things. So will we be touching upon those as well?
The main thing is we'll be going through real world projects, and okay, we'll be doing the scikit-learn practice data sets. They're actually pretty good, but to one point in the comments, they're not necessarily as dirty as real world data, but they do have enough dirt to get you some skills in that area. But like I'm promising, everything you just asked, you will want to ask those kind of questions again as we go through the projects. And that, because this is a project-centric course, it will help you see how to implement the pipeline. Surab.
Yeah, hi Tom. Actually, Shantanu already have raised the questions of CI/CD pipeline. So that was my question. So yeah, I got the answer.
Excellent. Now, guys, listen real quick. Some of you heard me be pretty nasty earlier on, and right now we're experiencing listen, you're going to have to miss some classes. Some of you are going to be late. I get that. I'm just asking you, treat this seriously. Show up on time. Next week, we will not wait for everyone to show up. We'll just get going. But don't miss the beginning. Get here early. That way we have more time for questions. The reason you sense me rushing is I want to give y'all a break before we start the mentoring session. So we're going to cut off here. Everyone give Guy a round of applause. That was awesome. Thank you, brother Guy. And feel free to drop. Remember, we have in our integrated workspace on Slack, we have pipeline class chat. We just decided to use that for all the TAs and all the student questions. That way, none of you are missing the questions that are being asked by everyone. So I'm gonna